In this video, I'm going to show you how to find the area of this piece of our circle. Okay, so before we were maybe finding something like a little piece like this, now we need to find the majority for this big piece of this circle. So the first thing we need to do here is actually draw some sort of diameter across this, because that's what we don't have. And typically on our circles, we always want a radius or a diameter measure, because to find area, we have to have some sort of radius, right? So this is our formula for the area of a sector. Right here we have our arc over 360 degrees times pi r squared, and our area for a triangle is half base height. And you might think, when am I ever going to use some sort of triangle for this picture? Well, I'm going to show you in just a second here. So let's draw our diagonals. We're going to draw them from one corner here to the other corner here of this pink shape that we have right through the center. Okay, maybe pick a different color for that. Oh, maybe a red here. So we have a little bit darker line. So there's one, and here is our other diagonal. Okay. So this splits our shape into two triangles and two sectors. And one really nice thing about these triangles and sectors is that the two triangles are the same size and the two sectors are the same size. So for our little formula that we're going to write up for this, we're going to use these two formulas that we already have and say the area of our shape here is 2 times the area of our triangle, right? 2 times this area, so 2 a triangle plus 2 times the area of the sector here. So 2 times the area of our sector. Okay, and that is what we're going to find here. So first of all, let's find that area of our triangle. Now, we don't really know much about this triangle except for that this length here is 20 and our degree here is 60. So I'm going to write that in. So we have a 60-degree angle. Okay, but to find the area of a triangle, we need a half base height. Okay, so let's split this into 2 pieces here, and we get a right triangle. Now, if we split the 60-degree angle in half, we end up with 30 degrees here and 30 degrees here. And now we have a nice 30, 60, 90 triangle. And we want to also split this length. This is going to be 10 here, and this is going to be 10. So looking at our top triangle up here, we're going to say, well, if this degree is 30 right here, this angle is 30 degrees, this is our short length 10, we need this height, okay, and that's across from our 60-degree triangle, and that is going to be 2 times that short length. This length here is going to be 20 also. All right, so our area of triangle. So we have half. A triangle is half times the whole base here is 20 times our height, which we just realized is also 20. Okay, and we multiply those together, we end up with 200. Okay, but it says up here that we need 2 times that area, so we're going to say 2 times the area of our triangle is 2 times 200, and we know that is 400, and this is units squared. So there's our area for our triangles. Now we need to find the area of our arcs here. So to get the area of an arc, okay, we're going to use, area of a sector. We use this nice formula up here, a sector. So our arc length on our sector right here is 120 degrees. So 120 divided by 360, multiply that by pi, and times our radius squared. Now we look at this and we say, oh, we actually don't know our radius yet. So we need to come back to our triangle and finish that with our 30, 60, 90 triangle. Our short side times the square root of 3 is going to give us that length out there. Now this is not drawn to scale, as you probably already noticed, but that's okay. It's still going to work out for us. So our radius here of our circle is 10 square root of 3 units squared. All right, so let's solve this equation. 120 over 360 reduces to 1/3, You may need to use your calculator maybe to help you with that. Some mental math skills there. Times pi times, well, 10 squared is 100, and the square root of 3 squared is just 3. 1/3 times 3 ends up being 1, so those will just go to 1, and then those are times 100 pi, there. So our area of our sector is 100 pi, but again, just like our triangle, we need to double that. So 2 area sector equals 2 times 100 pi, okay, and that is going to be 200 pi units squared. All right, so now coming back to our original formula up here, area equals 2 times our area of our triangle, which is 400, plus 2 times the area of our sector, which is 200 pi. And we cannot combine these because they're not like terms. So this is our units squared. Area